Hello students, this is me, your computer teacher Anurag Agrahari. My dear students, I hope you all are fine and doing well in your studies sitting at home. I also hope that you are following each and every guideline from the government to remain safe from this pandemic COVID-19. My dear students, I am here with the explanation of chapter 1, number system. In this chapter, we will understand what is a number system and what are different types of number systems and their conversion from one number system to another. Let's start. First of all, let us understand the number system. A number system is a set of values used to represent different quantities such as number of students in a class, number of viewers watching a particular show, your roll number in the class, your obtained marks in any subject, etc. My dear students, in the early days, when there were no means of counting, people used to count with the help of fingers, stones, pebbles, sticks, etc. These methods were not adequate and had many limitations. To overcome these limitations, we need a number system by the help of which we can do counting and calculation of any figure. Let us know the different number systems. As a definition, a number system is a set of values used to represent different quantities. There are 4 basic number systems used in the computers: decimal number system, binary number system, octal number system, and hexadecimal number system. Decimal number system is that number system which is used by human beings. Let us understand each one of them in detail. Students, you are watching a table here which is showing different types of number systems, the base or radix used into that, the number of digits used into that particular number system with an example. So first of all, the binary number system. The binary number system consists of only 2 digits, that is 0 and 1. Since this system uses 2 digits, that is why it is having the base 2. Let me tell you clearly what is a base. Just see the note given at the bottom of the slide. The total number of digits used in a number system is called its base or radix, and it is always written in subscript. You can see in the example how an octal number is written. 25 with the base 8. 8 is in subscript, showing the base. In the binary number system, you can see the example 1101 with the base 2. It shows the base 2 shows that it is a binary number. The next is octal number system. An octal number system uses the base 8, which means that there are total 8 digits in this number system. They are 0, 1, 2, 3, 4, 5, 6 and 7. The concept of octal number system came from the Native Americans, as they used to count numbers by using the space between their fingers rather than using their fingers. In the example 23 with the base 8 showing an octal number. Decimal number system. The decimal number system consists of 10 digits, that is 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each number can be used individually or they can be grouped to form a numeric value. For example, 76. Hexadecimal number. A hexadecimal number carries the base 16. Hex means 6 and decimal means 10. Hexadecimal means 16. This number system consists of 16 digits, that is 0 to 9, and the letters A to F, where A is equivalent to 10, B is equivalent to 11, C is equivalent to 12, D is equivalent to 13, E 14, and F 16. You can see in example, a number is written 5A7 with the base 16. Therefore, it represents that it is a hexadecimal number. Students, I hope that you have understood all the 4 types of number system, the digits they carry and the base they have. Let us know how one number system is converted into another. Actually, a computer cannot understand human language. Rather, it understands only the binary code. Therefore, the data that is entered into a computer is converted into its binary equivalent. Let us understand how a decimal number is converted into binary. Students, whenever we enter a decimal number into the computer for any type of calculation, the computer first convert it into binary and then do the further calculation. How does the computer convert that decimal number into binary? Let us have a look. We are going to convert a decimal number 28 into binary. The steps are, we need to divide the decimal number with 2 because we are going to convert a decimal number into binary number system. That is why we will divide the decimal number by 2. If the decimal number has to be converted in octal number system, then the division will be made by 8. In the same way, if a decimal number is to be converted into hexadecimal number, the number should be divided by 16. Let's see. The conversion of 28 decimal number into binary. So first of all, divide 28 by 2. We'll get 14 as quotient and 0 as remainder. Again repeat the step till the quotient is 0. Means divide again and again, the quotient returns until the quotient becomes 0. Let's see. 2 again divided 14, quotient 7, remainder 0. 2 divided 7, quotient is 3, remainder 1. 3 is again divided by 2, we will get the quotient 1 and the remainder 1. Now 1 will be divided by 2 because 1 is undivisible by 2, so we will divide it by 0. We will get the remainder 1. So this was the division process done by the computer to convert a decimal number into binary, but it is not the final of the procedure. Some more steps are left. To understand those steps, first understand the LSD and MSD. LSD means the least significant digit and MSD means most significant digit. So after doing the division, we have to write the obtained remainders from the bottom to up from MSD to LSD, like 11101. It is very important to note, students, that you have to write all the remainders from the bottom to top. So the binary value of 28 is 11100. Let's have a look of the steps how the procedure is done. To convert a decimal number into binary, follow the given steps. Divide the given decimal number with the base 2. Step 2. Write the remainder and divide the quotient again by 2. Step 3. Repeat the step 2 until the quotient becomes 0. Step 4. Write the remainders obtained in each step in the reverse order to form the binary equivalent of the given decimal number, that is, placing the least significant digit at the top and the most significant digit at the bottom. Let's have one more example. 75, a decimal number to be converted into binary. So what we will do? We will divide the number by 2 until the quotient becomes 0. So 75 divided by 2, we obtained the quotient 37 and the remainder 1. Then again 37 is divided by 2 and we obtain the quotient 18 and remainder 1. In the same way, we repeat the division process until we get the quotient 0. After the division process, we will check out the LSD and MSD, and we will write all the remainders from MSD to LSD to obtain the binary equivalent, that is 1001011. Now students, I hope that you have understood the conversion of a decimal number system into binary number system. You can do the practice at home by selecting any decimal number and applying the given process onto that to obtain the binary equivalent. Students, when we enter any number in the computer or a calculator to do some arithmetical process, first of all that number is converted into binary. After the calculation, computer gives the result in decimal form so that we can understand that. But actually the decimal number which we get as a result is obtained by converting the binary result into the decimal. Whenever we enter in a decimal value into the computer for any calculation, computer converts that decimal into the binary, then do the calculation, again it converts the binary into decimal and then presents the result on the screen. So how that binary numbers are converted into decimals, let us understand that. For example, we have to convert 1011 into decimal number. So for that, the first step we will do that what? We will write all the binary digits on the paper. Then from the right hand side we will place powers. As you can see in the given example, the rightmost digit, that is 1, is having the power 0. In the same way, we will place the powers to each and every digit from right to left, starting from 0, 1, 2, 3 and so on. See to it. Yes, like this. Now the second step is to take one digit from right and multiply it with 2. Put the same power on the 2 which is with the binary digit, that is 0. Students, I hope that you are knowing that if a number is having a power 0, it is equals to 1. That's why 1 into 2 to the power 0 is equals to 1. 2 to the power 0 is equals to 1, and then 1 into 1 is equals to 1. Now let's solve the another digit, that is 1 into, again multiply it with 2, but put the power 1 because this digit is having power 1 on itself. So 1 into 2 to the power 1 is equals to 2. Take the next digit, multiply it with 2 with the respected power on that particular digit. So 0 into 2 to the power 2 is equals to 0. How? 2 to the power 2 is equals to 4, and 4 into 0, 0. Now take the last digit, that is 1. Do the same procedure, 1 into 2, and put the same power which is on the digit, that is 3. 1 into 2 to the power 3, that is 8. Now the last step is to add all the obtained results. 11. So 11 is the answer. 1011 of binary is equals to 11 of decimal. Let's check the steps in writing. To convert a binary number into decimal, follow the given steps. Step 1. Put powers to all the digits starting from 0, 1, 2 and so on. But don't forget that you have to do powering from right to left. Step 2. Multiply each binary digit with 2 to the raised positional power. Step 3. Calculate sum of all the products to get the decimal number. Let's have one more example. Convert 111 into decimal equivalent, means 111 of binary into decimals, means the human readable format. First of all, write all the digits, then start placing the powers starting from 0, that is 0, 1, 2, and then take the rightmost digit, multiply it with 2 with the raised power 0. The result is 1. Why? Because 2 to the power 0 equals to 1, and 1 into 1 equals to 1. Take the another digit, that is 1, multiply it with 2 with the same power on the digit, that is 1. In the same way, do the same procedure with the third digit. 1 into 2 to the power 2 equals to 4. After doing all the digit operations, sum up all the products. We get the result 7, and this is our decimal equivalent. So 111 of binary is equals to 7 in the decimals. Students, I hope that you have understood all the types of number systems and the conversion of decimal to binary and binary to decimal. In the next part, we will learn the binary arithmetic. That means the addition, subtraction, multiplication and division of the binary values. Till then, students, stay home, stay safe.